Hello, everyone. Welcome to our today's PowerPoint presentation on design patterns, part 4. This video is brought to you by Newton's Group of Institutions, Macharla. This is Yegireddy from the Department of Computer Science and Engineering. In this video, we will discuss about creational patterns. Today, we are going to cover this particular topic from the book Design Patterns by Eric Gama, Pearson Education. In the previous lectures, we have discussed the topics creational patterns, its introduction, abstract factory, builder, and factory method. And in this lecture, we will discuss about prototype and singleton. Here, the intent of the prototype specify the kind of the objects to create using a prototypical instance and creates a new object by copying this prototype. That is, prototype is a creational design pattern that lets us copy the existing object without making our code depending on the classes. Now coming to the motivation. Here, we could build an editor for the music score by customizing a general framework for the graphical editor and adding the new objects that represents the notes, rests, and staves. So the editor framework may have a palette of tools for adding these musical objects to the score. The palette would also include tools for selecting, moving, and otherwise manipulating the music objects. So here the users will click on the quarter note tool and use to add quarter notes to the score, or they can use the move tool to move the note up and down on the staff and thereby changing its pitch. Now let us assume the framework which provides an abstract graphic class for the graphical components like notes and staves. Moreover, it will provide an abstract tool class for defining the tools like those in the palette. So the framework also predefines a graphical tool, subclasses for the tools that create the instance of the graphical objects, and add them to the document. But the graphical tools present a problem to the framework designer. Here, the classes for the nodes and staves are specific to our application, but the graphical tool class belongs to the framework. So here, the graphical tool does not know how to create the instance of our music class to add to the score. And we could subclass the graphical tools for each kind of the music object, but that would produce lots of subclasses that differ only in the kind of the music object they instantiate. So we know that the object composition is flexible, alternative to the subclassing. So here the question is, how can the framework use it to parameterize the instances of the graphical tool by the class of graphics they are supported to create? So here the solution lies in making the graphical tools create a new graphics by copying or cloning an instance of the graphic subclass, and we call this instance as a prototype. A graphical tool is parameterized by the prototype. It should clone and add to the document. If all the graphic class subclasses, if they support a clone operation, then the graphic tool can clone any kind of the graphic. So in our music editor, each tool for creating a music object is an instance of a graphical tool that initializes with a different prototype. So here each graphical tool instance will produce a music object by cloning its prototype and adding the clone to the score. So here we can use the prototype pattern to reduce the number of classes, and even further we have separate classes for the whole notes and half notes, but that is which is probably unnecessary. So instead what we do is they could be instances of the same class initialized with the different bitmaps and durations. So here the tool for creating the whole nodes become just a graphical tool whose prototype is a musical note which is being initialized to be a whole note. So this can reduce the number of classes in the system dramatically, and it also makes it easier to add a new kind of note to the music editor. Now coming to the applicability, use the prototype patterns when the system should be dependent on how its products are created, compared and represented. And when the classes to instantaneous are specified at runtime, for example, for dynamic loading, or we need to use the prototype patterns to avoid building a class hierarchy of the factories that parallels the class hierarchy of the products. Or we use the prototype patterns when the instances of a class can have one of the only a few different combinations of the state. So it may be more convenient to install a corresponding number of the prototype and clone them rather than instantiating the classes manually each time with the appropriate state. So here coming to the structure. So here the prototype interface declares the cloning method, which is almost in most cases it is a single clone method. And the concrete prototype class which implements the cloning method. So in addition to copying the original object data to the clone, this method may also handle some edge cases of the cloning process which are related to the cloning linked objects, untangling the recursive dependencies, etc. So here the client can produce a copy of any object that follows the prototype interface. Now coming to the participants. Here prototype, that is the first participant prototype, which is a graphic which declares an interface for cloning itself. Concrete prototype, they are the staff, whole note and half note, which implements an operation for cloning itself. And client is which is a graphical tool which is used to create a new object by asking a prototype to clone itself. And coming to the collaborations, a client asks a prototype to clone itself. Now let us see some of the consequences. Here, prototype has many of the same consequences what the abstract factory and builders have. So here it hides the concrete product classes from the client, thereby reducing the number of names the client knows about. So moreover, these patterns let the client work with the application specific classes without doing any modifications. So here the additional benefits of the prototype pattern are adding and removing the product at runtime. So here the prototype lets us incorporate a new concrete product class into the system simply by registering a protocol or prototypical instance with the client. That is a bit more flexible than other creational patterns because a client can install and remove the prototype at the runtime. And the other benefit is it specifies a new objects by varying values. So here highly dynamic systems which let us define new behaviors through object composition or by specifying the values for the objects variables. For example, not by defining the new classes, we effectively define new kind of objects by instantiating the existing classes and registering the instances as the prototype of the client objects. Here, a client can exhibit the new behavior by delegating the responsibility to the prototype. So this kind of design which lets the users define new classes without programming. So in fact, cloning a prototype which is similar to instantiating a class and the prototype patterns can greatly reduce the number of classes a system that needs. So in our music editor, one graphical tool class can create a lifetime are timeless variants of the music objects. And the third benefit is specifying new objects by varying structures. So many applications that are being used to build the objects from parts and subparts. So here the editors for circular design, for example, build the circuit out of a sub-circuits. For convenience, sub-applications often let us instantiate the complex user-defined structures, say to use a specific subscript again and again. So here the prototype pattern supports this as well. We simply add this subscript as a prototype to the palette of variable circuit elements. So as long as the composite circuit object implements clone as a deep copy, the circuit with the different structures can be prototypes. The fourth benefit is it reduces the subclassing. So here the factory methods which often produces a hierarchy of creator classes that parallels the product class hierarchy. So the product patterns lets us clone a prototype instead of asking a factory method to make a new object. Hence, we don't need to create a class hierarchy at all. So we don't need to create the class hierarchy at all. So this benefit which applies primarily to the languages like C++ that don't treat classes as an first class objects. So languages that do like Smalltalk and Objective-C, they derive less benefits, of course. Since we can always use a class object as a creator, class objects which already act like prototypes in these languages. Now coming to the fifth benefit, configuring an application with classes dynamically. So here some runtime environments that let us load the classes into the application dynamically. So here the prototype pattern is the key to the exploiting such facilities in the languages like C++. So here an application that wants to create an instance of a dynamic loading class won't be able to reference its constructors statically. So instead, the runtime environment, it creates an instance for each class automatically when it is loaded, and it registers the instance with a prototype manager. So here, the application can ask the prototype manager for instance of the newly loaded classes or classes that were not linked with the program originally. So here the ET++ application framework has a runtime system that uses this schema, and the main liability of this prototype pattern is that each subclass of the prototype must implement the clone operations, which may be difficult. For example, adding clone is difficult when the classes under considerations which already exist. So implementing clone can be difficult when their internals include objects that don't support copying or have circular references. Now coming to its implementation. So here the prototype is particularly useful with the static languages like C++, where classes are not objects and little or not type information is available at the runtime. So it's less important in the languages like Smalltalk or Objective-C, which provide what amount of prototype for creating the instances of the each class. So this pattern is built into prototype-based languages like Self, in which all the objects created are happened by cloning a prototype. Now let us consider the following issues when implementing the prototype. The first issue is using a prototype manager. So here when the number of prototypes in the system is not fixed, then we need to keep a registry for available prototypes so that the clients won't manage the prototype themselves but will store and retrieve them from an registry. So here a client will ask the registry for the prototype before cloning it so that we can call this registry at the as a prototype manager. So a prototype manager is an associative store that returns the prototype matching by a given key. So it has operations for registering the prototype under the key and for understanding it. Here, the clients can change or even browse through the registry at runtime, so that it lets the clients extend and take the inventory on the system without writing any code. Now, the second issue is implementing the clone operation. The hardest part of the prototype pattern is implementing the clone operation correctly. So it's particularly tricky when the object structure contains the circular references. So most languages, they provide some support for cloning objects. For example, Smalltalk, which provides an implementation of the copy that is inherited by all the subclasses of the object. So here, a shallow copy is simple and which is often sufficient, and that's what a Smalltalk which provides by default. So here the default copy constructor in C++ does a member-wise copy, which means the pointers will be shared between the copy and the original. But here the cloning prototype with complex structures usually require a deep copy because the clone and the original must be independent to each other. Therefore, we must ensure that the clones components are clones of the prototype components. Here, the cloning forces us to decide what, if anything, will be shared. So if the objects in the system provide save and load operations, then we can use them to provide the default implementation of the clone by simply saving the objects and loading it back immediately. So the save option, which saves the object into the memory buffer, and the load creates a duplicate by reconstructing the object from the buffer. And the third issue is initializing clones. So while some clients are perfectly happy with the clone as is, others will want to initialize some or all of its internal states to values of their choosing. So we generally cannot pass these values in the clone operation because their number will vary between the classes of prototypes. So some prototypes might need multiple initialization parameters and other won't need at all any. So passing these parameters in the clone operation precludes the uniform cloning interface. So it might be the case that our prototype classes, which are already defined with some operations for setting the key pieces of the state. So if so, the client may use these operations immediately after the cloning. If not, they may have to introduce an initialize operation that takes the initialization parameters as an argument and set the clone's internal state accordingly. So here we need to be aware of deep copying clone operations. Here the copies may have to be deleted or before we initialize them, either explicitly or with by initializing it. Now, coming to the singleton, here the intent of the singleton is to ensure a class only that has one instance and which provides a global point of access to it. So here singleton is a creational design pattern that lets us ensure that the classes has only one instance while providing the global access point to the instance. Now coming to the motivation, it's important for some classes to have exactly one instance. Although there can be many printers in the system, there should be only one printer spooler. So there should be only one file system and one window manager. So here a digital filter will have an AD converter. An accounting system will be dictated to service one company. So here how do we ensure that the classes has only one instance and that instance is easily accessible? To do that, a global variable which makes an object accessible, but it does not keep you from instantiating the multiple objects. So a better solution is that to make the classes itself responsible for keeping track of its sole instances, the class can ensure that no other instance can be created and it can be provided a way to access the instance. This is the singleton pattern. Now coming to its applicability, we use the singleton patterns when there must be exactly one instance of the class and it must be accessible to the clients from a well-known access point. Or we use the singleton patterns when the clone instance should be extendable by the subclassing and the client should be able to use an extended instance without modifying their code. So here, let us see the singleton structure. Here, the singleton class declares the static method getInstance. So here, getInstance is a static method which returns the same instance of its own class. So the singleton's constructor should be hidden from the client code, and calling the getInstance method should be the only way of getting the singleton object. Now coming to the participants in singleton, here defines an instance operations that lets the client access its unique instance. Here instance is a class operation that is a class or a method in the Smalltalk and a static member function in the C++, may be responsible for creating its own unique instances. And coming to the collaboration, here the client accesses a singleton instance solely through a singleton's instance operation. Now let us see some of the consequences. So in singleton pattern, it has several benefits, and the first benefit is controlled access to the sole instance. Because the singleton class which encapsulates its sole instance, it can have a strict control over how and when these clients can access it. And the second benefit is reduced namespace. The singleton pattern is an improvement over global variables and it avoids polluting the namespace with global variables that store the solo instance. And coming to the third advantage, they permit refinement of operations and representations. Here, the singleton class may be subclassed and it's easy to configure an application with an instance of these extended classes. So we can configure the application with an instance of the class we need to run or at a runtime. And the fourth benefit is it permits a variable number of instances. Here, the patterns make it easy to change our mind and allow more than one instance of the singleton class. So moreover, we can use the same approach to control the number of instances that the application uses, and only the operation that grants the access to the singleton instance need to get changed. And the fifth benefit is more flexible than class operations. So this is another way to package a singleton's functionality, which is to use the class operations, because both of these language techniques which make it harder, whether it can be the Smalltalk or it can be a C++, both of these language techniques make it harder to change a design to allow more than one instance of the class. And moreover, the static member functions in the C++ are never virtual. So subclasses cannot override them polymorphically. Now, coming to its implementation, ensuring a unique instance. So here the singleton pattern makes the sole instance, a normal instance of a class. But that class is written so that only one instance can ever be created. And a common way to do this is to hide the operation that creates the instance behind the class operation. That is either a static member function or a class method that guarantees only one instance that is being created. So this operation which has the access to the variables that holds the unique instance, and it also ensures the variables which is initialized with the unique instance before returning its value. So this approach ensures that a singleton is created and which is being initialized before its first use. So we can define the class operations in C++ with a static member function and instances of the singleton class. So here the singleton, which also defines a static member variable underscore instance that contains a pointer to its unique instance. Here the singleton class is declared as the corresponding implementation, and singleton star singleton instance is equal to 0. So here the client access the singletons which executively through the instance member function. So here the variable instance is initialized to 0 and the static member function instance returns its value which is initialized with the unique instance of it. So instead uses lazy initialization and the value returns its which is not created and stored until it is being first accessed. Here you can notice that the constructor is protected and the client that writes the instantiation of the singleton directly will get an error at the compile time. This ensures that only one instance can ever get created. So moreover, since the underscore instance is a pointer to a singleton object, the instance member function can assign a pointer to a subclass of singleton to the variables. And we will give an example of this in a sample code. So there are another things to note about the C++ implementation. It's not enough to define the singleton as a global or static object and they rely on the automatic initialization, because there are three different reasons what we can say. We cannot guarantee that only one instance of the static object will ever be declared. And the second reason could be we might not have enough information to instantiate every singleton at the static initialization time. And the third reason could be C++ does not define the order in which these constructors for the global objects are called across the translation units. This means that no dependency can exist between the singletons. If any do, the errors are inevitable. Now, coming to the subclassing the singleton classes. So here, the main issue is not as much defining the subclasses, but installing its unique instances so that the client will be able to use it. In essence, the variables that refer to the singleton instances must get initialized with an instance of the subclass. And the simplest technique is to determine which singletons we want to use it in the singletons instance operation. An example in the sample code which is being shown how to implement this technique with environment variables. And another way to choose the subclass of the singleton is to take the implementation of the instance out of the parent class and put it in the subclass. So here C++ programmer who decide the class of singleton at the link time, but they keep it hidden from the clients of the singleton. because the link approach which fixes the choice of the singleton class at the link time, which makes it harder to choose the singleton class at the runtime. So using conditional statements to determine the subclasses is more flexible, but it hardwire the set of possible singleton classes. Neither approach is flexible enough in all the cases. So a more flexible approach which uses a registry or singletons. So here, instead of having the instance, we need to define the set of possible singleton classes, and the singleton classes can register their singleton instances by the name in a well-known registry. So the registry map, which maps between the string names and the singletons. When instances needs a singleton, it consults the registry asking for the singleton by its name. So the registry looks up the corresponding singleton and returns it. So this approach frees the instance from knowing all possible singleton classes or instances. So all it requires is a common interface for all the singleton classes that include the operations for the registry. Thanks. If any queries, you can contact me at arvind.ynd@newtons.edu.in, and you can call me at 9494470795. That's all for now. If you like this video, please press the bell icon and subscribe the channel for the latest notifications.